Hi guys, so can you solve this Olympiad math question? Now this question requires a little bit of trick for us to solve. When you try to solve for the x for the value of x directly here, you're going to get a very wrong answer, and it's going to be very hard for us to do that. Now how can we solve this question here on the board? Now the question says that if x plus 1 over x equals square root of 13, then 3x all over x squared minus 1 will give us what? Now, we're going to solve this question by easy substitution. What does that mean? Since we know the value of x plus 1 over x, and we need the value of this, what we are going to do is that we are going to try to express this in terms of x plus 1 over x. We break this down and express it in terms of x plus 1 over x, and then we substitute, as simple as that. Now, how can we break this down to give us this? So, how do we do that? Now, when we look at this question here now, we have square here. We don't have any squares here. We have a fraction of x. We don't have a fraction of x here. So we have to get rid of this square and incorporate a fraction of x in this expression here. So how are we going to do that? What we are going to do is that we are going to try to divide the numerator and the denominator of this expression here by x. What am I talking about? We divide 3x by x, then we divide x squared minus 1 by what? X. I haven't done anything wrong because x can easily cancel out x, okay? So divide the numerator and denominator by x. So by simplifying here now, we're going to have x cancels x, we're left with 3 all over. Now, because this x is a common denominator, we can split it, okay? So we can have x squared all over x minus 1 all over x, okay? So this x can cut one of these, then we have 3 over x, 3 over x, yes, then minus 1 all over x. As simple as that. Now I've gotten rid of the square, I've introduced the fraction here. Now, we are almost there, but we're not there yet because we should have substituted root 13 into this equation directly, but there's one more problem. The problem is that this here is positive, while here is negative. So we have to express this negative in terms of this positive term here, okay? So what are we going to do? How are we going to do this now? We're going to use algebraic identity. So what identity can we use here now? So we're going to use the alpha beta identity. Now, let's assume x to be alpha minus 1 over x to be what? Beta. Now, what identity can we use here? How can we convert this minus to plus here that we need? Okay, so what we're going to do is that, first of all, the algebraic identities that we know mostly contains squares, cube, and power. But this one does not have any power, does not have any square. So we have to incorporate square into this. And how can we do that? Mathematically, we can write this as alpha minus beta all squared. Then we take the root. Okay, mathematically we haven't done anything wrong because square cancels out root and we still have alpha minus beta. So we haven't done anything wrong. Okay, so we use the identity for alpha minus beta squared. So the identity for alpha minus beta squared is, that gives us square root of alpha squared plus beta squared, then minus 2 alpha beta. That's the identity for this, okay? We are getting very close. Now we have addition here, but here we have addition here, but here now is squared, here is not squared. So we still have to break this down one more time, okay? So alpha squared plus beta squared also, we use another identity for that. So we can write this as, please, these identities can be found online, okay? Algebraic identities, that's for factorization and expansion. And I'm also going to make videos on that also. We can check them out, okay? In case you are not familiar with this. So alpha squared plus beta squared will give us alpha plus beta all squared minus 2 alpha beta, okay? Then minus 2 alpha beta here. We have converted this to this then. So finally, we now have square root of alpha plus beta all squared minus 4 alpha beta. As easy as that. So that means we're going to express x minus 1 over x in terms of this, okay? The same thing, x minus 1 over x, alpha minus beta in this form. Then we express this one also in this form. I haven't done anything wrong. So we're going to have 3 all over. Now we're going to use this substitution here. But instead of x, we have alpha. 1 over x, we use beta. So we're going to have square root of x plus 1 over x all squared minus 4 times x times 1 over x. Okay? We are getting there. Let's continue here. Okay? So we can simplify this further because x can cancel x. Then here we have square root of x plus 1 over x all squared minus 4 minus what? 4. Okay, so I've simplified this and I've gotten this. Therefore, it's going to give us 3 all over square root of alpha plus x plus 1 over x all squared minus 4. Now you can see that we have converted this equation to this. We have expressed this in terms of x plus 1 over x. Easy. Now we can use our substitution to get our final answer. That's just the idea there. We take this and we express it in terms of this. We have gotten that here with the help of our algebraic identities. Okay, so here we can use direct substitution. Whenever we see x plus 1 over x, we input root 13. So here we have 3 divided by square root of root 13 squared minus 4. That will give us 3 all over square root of root 13 squared gives us what? 13. Okay, so we have 13 minus what? 4. Okay, so let's continue. Now here we can say 13 minus 9 is 13 minus 4 is 9. So here we have 3 all over square root of what? 9. Therefore, that will give us 3 over what? 3, because square root of 9 is 3. Then our final answer will now be what? 1. Therefore, 3x all over x squared minus 1 is 1. Our final answer. Very, very what? Simple. It's just about manipulation and knowing how to use the algebraic identity. It's not hard. Okay? Now, please don't forget to subscribe to my channel if you want to learn more tricks like this and as a way of supporting me. So till I come your way next time, bye-bye.